Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter solutions and colligative properties. So any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also, in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section, so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter of chemistry will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told, which of the following aqueous solutions has the highest freezing point? So we know that the depression in freezing point delta TF, that is equals to I into M into Kf, where Kf is the constant used for the depression in freezing point, and M is the molality, and I is the Van 't Hoff factor. So for the option A, I equals to 2, since it will give two ions, which are Na plus ions and Cl minus ions, and molality we can tell that is equal to 0.01 only. If 1 kilogram of solvent is used, 1 kilogram of water is taken in all the cases, and therefore the value of I into M will be 0.02 here. So here the Kf, which is the Kf for water, that will be constant for all the solutions. So it means that the depression in the freezing point will be higher if the I into M value is higher. So the I into M value for this sodium chloride solution is 0.02, and for option B it is 0.01 molar Na2SO4. So here molality is 0.01 only, and Van 't Hoff factor will be 3, since it will give 3 ions, 2 Na plus ions and 1 sulfate ion. Therefore here I into M will be 0.03. So here the rule is that delta TF is the depression in the freezing point, which is which is the normal freezing point of pure water minus the freezing point of the solution. So therefore, if the depression in the freezing point is lesser, then only the freezing point of the solution will be higher. So it means that the depression in the freezing point should be the least, so as to obtain the highest freezing point. So I into M value is 0.03 for the sodium sulfate solution. Then for the option C, that is 0.1 molar sucrose. So here the Van 't Hoff factor I for sucrose is 1, since it will give no ions. No ions will be formed. Only one single uh, molecule will be there. And molality is 0.1. So therefore I into M value is 0.1 only for the sucrose solution. And for option D, that is 0.1 molar NaCl. So here NaCl solution. So here I is equal to 2, since it will give two ions, sodium ion and chloride ion, and molality is 0.1. So therefore I into M value is 0.20. Here also I can write 0.10. So therefore here I into M value is the highest, and the I into M value is the least for this option A in the 0.01 molar NaCl solution. So here, since the I into M value is the least, so the depression in freezing point is the least here for the option A, and so it will have the highest freezing point. So it has the highest freezing point. So option A is the correct answer. Then here it is told which of the following is not a colligative property: osmotic pressure, optical activity, depression in freezing point, elevation in boiling point. So optical activity, it depends on the nature of the solute. Optical activity, it depends on the nature of the solute. It depends on the nature of the solute. It means that if the solute is an optically active substance or not. Um, so it means that it is not a colligative property. Since why colligative property, it means properties, those pro- properties which depend only on the concentration on the of the solute, which so it means so colligative property, it means those properties which depend only on the mm, concentration of the solute, concentration of the solute, or the number of particles, or on the number of particles, and it is independent of the nature of the solute. and and it is independent on the nature of the solute, independent of the nature of the solute. So so this osmotic pressure, pi, it is ICRT, where C is the concentration of the solute. So it depends only on the concentration of the solute, and the depression in freezing point, and the so it is also I into M into KF, and the elevation in boiling point, that is also I into M into KB, where M is the molality of the solution and I is the Van 't Hoff factor. So therefore, the osmotic pressure, depression in freezing point, elevation in boiling point, all these are colligative properties only. But optical activity is not a colligative property. So option B is the correct answer. Then it is told when an electrolyte is dissociated in the solution, the Van 't Hoff factor I is. So when an electrolyte, let's say AN, it is dissociated, then it forms N molecules, N atoms of A. So then, so uh, here the Van 't Hoff factor I is given as 1 plus alpha into N minus 1, where alpha is the degree of uh, dissociation, where alpha is the degree of dissociation of the solute. So therefore, that I is, so therefore I can say I is more than 1. So option A is the correct answer. Then here it is told osmotic pressure of the solution can be increased by increasing the temperature of this solution. So as we know, osmotic pressure of the solution pi, that is equals to ICRT, where T is the absolute temperature of the solution, R is the ideal gas constant, and C is the molar concentration of the solution, and I is the Van 't Hoff factor. So it means that I into N by V into RT. So it means that if we want to increase the osmotic pressure, then either we can decrease the volume so as to increase the concentration of the solution, or we can increase the temperature of the solution. So osmotic pressure can be increased by increasing the temperature of the solution. So option A is the correct answer. Then it is told which of the following aqueous solution has highest freezing point. So as we know that the depression in freezing point delta TF, that is equals to I into M into KF, where KF is the constant which is used in the depression in freezing point, and M is the molality of the solution, and I is the Van't Hoff factor. Now for the option A, the so as we know that the depression in freezing point, that is equals to TF naught minus TF. It means that it is the freezing point of the pure solvent minus the freezing point of the solution. So therefore, if the depression in freezing point is the least, then only the then only the freezing point of the solution will be the highest. Then only the depression in the yeah. So if the depression in the freezing point is the least, then only the freezing point of the solution is the highest. So now for the option A, it is told Al2 SO4 whole thrice. So here the Van't Hoff factor I will be 5, since it will give 5 ions in the solution, 2 ions of Al and Al3 plus and 3 sulfate ions. So therefore, so here Kf will be same for water for all the 4 solutions. So it means that I into M value should be highest. So I into M value should be the least. Only that only will have the highest freezing point. So here I into M value will be 5 into 0.1, so that is 0.5. And in the option B, that is 0.1 molar BaCl2. So here I is equal to 3, since it will give 3 ions in the solution, and so therefore I into M value will be, and here as we know that as we can see that the molality value is also the same. So it means that if the Van't Hoff factor is the least, then only the depression in freezing point will be the least. So here the Van't Hoff factor in the option C, the Van't Hoff factor for AlCl3 is 4, since it will give 4 ions, and for option D the Van't Hoff factor is 2, since it will give 2 ions. One is the ammonium ion NH4 plus and Cl minus ions. So Van't Hoff factor is the least for the option D in ammonium chloride. So therefore here the depression in freezing point will be the least, so the freezing point will be the highest. So option D is the correct answer. Then here it is told that when the pure solvent diffuses out of this solution through the semi-permeable membrane, then the process is called. So if the solvent moves inside the solution through the semi-permeable me- membrane, then that process is called as osmosis. But here the opposite is happening. It means that the solvent is moving out of the solution through the semi permeable membrane, so it is the process of reverse osmosis. So option D is the correct answer. Then it is told the Van't Hoff factor I accounts for the extent of dissolution of the solute, the extent of dissociation of the solute, extent of mobility and solubility of solute. So the Van't Hoff factor I, as we know that in case of dissociation, in case of dissociation, in the case of dissociation of the solute, I is given as 1 plus alpha into n minus 1. So it gives, so the Van't Hoff factor I, it depends on the degree of dissociation alpha. Here alpha is the degree of dissociation. So it means that the Van 't Hoff factor I, it depends on the degree of dissociation of the solute. So therefore, the Van 't Hoff factor I accounts for the extent of dissociation of the solute. It depends on the extent of dissociation of the solute. Option B is the correct answer. Which of the following aqueous solutions should have the highest boiling point? Which of the following aqueous solutions should have the highest boiling point? So here you know that the elevation in the boiling point delta TB, that is given as I into m into kb, where kb is the constant used for the mm, elevation in boiling point. So now the elevation in boiling point delta TB, that is given as TB minus TB naught. It means the boiling point of the solution minus the normal boiling point of the pure solvent. So now therefore if the elevation in boiling point is the highest, then only the boiling point of the solvent will be the highest. The boiling point of the solution will be the highest then. So here it means that we need to find which one has the highest boiling point. It means we need to find which one has the highest elevation in boiling point. So now here the m- molality is the same. All has the concentration one only. Uh, Here suppose we assume that the solvent taken is 1 kg only. So it means the molality will be same as the molality only. Ap- a- Approximately it will be same as 1 only. So therefore now, and kb will be also same for all the four solutions, since kb it is used for the pure solvent only, so it will be the same. So therefore if the Van 't Hoff factor I value is higher, then only the elevation in boiling point will be higher. So now for the option A, the Van 't Hoff factor is 2, since it will give two ions. One is sodium ion and hydroxide ion in the solution. And for option B, the Van 't Hoff factor I is 3, since it will give three ions, two Na plus ions and one sulfate ion. And in option C, the Van 't Hoff factor is 2, since it will give, and in the option C it is given wrong. It should be NH4NO3. It is one ammonium ion and one nitrate ion. So it will give two ions in the solution. And in option D, the Van 't Hoff factor I is 2, since it will give two ions in the solution. And so therefore the I value is the highest in case of option B. So in option B only the elevation in boiling point will be highest, and so the boiling point of the solution also will be highest. So option B is the correct answer. Then here it is told isotonic solutions are having the same isotonic solutions. Isotonic s- s- solutions, it means that which have the same osmotic pressure. It means isotonic solution, it means their molar concentration is the same. So if C is same, then we know that osmotic pressure pi equals to ICRT. So if the concentration is same, it means the osmotic pressure also will be the same. So isotonic solutions have the same osmotic pressure. So option C is the correct answer. So then it is told relative lowering of vapor pressure of a dilute solution of glucose dissolved in 1 kg of water is 0.002. The molality of the solution is. Now here, as we know that the relative lowering of vapor pressure, that is given as P naught minus Ps by P naught. So where P naught is the vapor pressure of the pure solvent minus Ps is the vapor pressure of the solution, and so P naught minus Ps by P naught will give you the relative lowering of vapor pressure, and that is actually given as the number of moles of solute by number of moles of solvent. Now therefore 0.002, that will give us the number of moles of the solute, that is glucose, that is used, divided by the number of moles of solvent. So 1 kg is used, so 1000 gram by 18 gram. So this will give us the number of moles of the water that is used. So therefore the number of moles of glucose used, that is equals to so 2 by 18, that is equal to 1 by 9 mole. So therefore the molality of the glucose solution, that will be equal to number of moles of glucose divided by the number of no the mass of the solvent in kg. So that will give us 1 by 9 divided by 1. So 1 by 9 molal, or you can say 0.111 molal approximately. So option C is the correct answer. Then it is told non-volatile solute A tetramerizes in water to the extent of 80%. So tetramerizes, it means that 4 atoms of A will combine to form A4. Since it tetramerizes to the extent of 80%. So therefore of association, the degree of association is 0.8, which is 80%. So now therefore for degree of uh, so therefore association for association of the solute, the Van 't Hoff factor I is given as 1 plus alpha into 1 by n minus 1. And here n is equal to 4 actually, since it tetramerizes. So therefore it is 1 plus 0.8. So the degree of association alpha is 0.8. So 1 plus 0.8 into 1 by 4 minus 1. So that will be 1 minus 0.8 into 3 by 4. So that is 4 to the 8, 2 3 is 6. So 1 minus 0.6, that is 0.4. Now it is told that so 2.5 gram of A is used in 100 gram of water. So it lowers the freezing point by 0.3 degrees Celsius. So now therefore, as we know, the depression in freezing point delta TF, that is equals to I into M into KF. Now KF value for water is given 1.86 Kelvin kg per mole, and the Van 't Hoff factor is 0.4 only, and the molality of the solution, and therefore molality, that will be equal to 2.5 gram of A is used, divide by X. Let's say that X gram is the um, m- molar mass of A. X gram is suppose the molar mass of A. So that divided by 100 gram of water, so 0.1 kg of water. So therefore the m- molality of the solution is 25 by X molal. So therefore, so we can say that delta TF that is depression freezing point is 0.3 degrees Celsius. So 0.3 equals to 25 by x into I, that is 0.4, into kf, that is 1.86. So this will be equal to 0.3 into 25 4 is 100. So 10 into 1.86, so 18.6 divided by x. So x will be equal to 186 by 3. So that is 3 6 18, 3 0 6. 3 0 6, okay. So 62 gram. So 62 gram is the, so, or 62 gram per mole, it is the molar mass of A. So option A is the correct answer. Then it is told solution A contains acetone dissolved in chloroform. Solution A, it contains acetone. Acetone means CH3CO, CH3. It is dissolved in chloroform, which is CHCl3. And solution B contains acetone, which is CH3CO, CH3, dissolved in carbon disulfide, CH2. Now, the type of deviation from Raoult's law is shown by A and B. The solutions A and B are. So, the solution A will show a negative deviation from Raoult's law, negative deviation from the Raoult's law. Since why here the here the in this case of solution A, its boiling point will be more than the normal boiling point. And in case of solution B, it will show the positive deviation from Raoult's law. Positive deviation from Raoult's law, since it's here the boiling point of the solution will be less than the normal boiling point. So negative and positive. So option D is the correct answer. Then it is told which of the following pair of solutions is isotonic. So now, therefore, we know that the osmotic pressure, that is pi, is given as ICRT. So therefore, so I can say that if I into C, which is the Van 't Hoff factor times the Van 't Hoff factor times the molar concentration of the solution, if that is same, then only the osmotic pressure will be same, and then only we can say that the solutions will be isotonic solutions. So now in case of option A, the Van 't Hoff factor I is 5, since it for Al2SO4 whole thrice for aluminum sulfate, since it can give 5 ions in the solution, and therefore the I into M value for aluminum sulfate, that is 0.005. Similarly, for the second solution BaCl2, here I will be equal to 3, but here the I into M value will be 0.03. So it means they are not same. So they are not isotonic. Uh, but in the case of option D, we see that here the Van 't Hoff factor for BaCl2 is 3, since it can give 3 ions, and I into M value, that will be 0.1 into 3, that is, sorry, 0.01 into 3, that is 0.03. And for NaCl, the Van 't Hoff factor I is 2, and so the Van 't Hoff factor I into the molality of the solution, that will be 0.015 into 2, so that will be again 0.03. So since the I into m value is same, so their osmotic pressure pi will be also same, so they are isotonic solutions. So option D is the correct answer. When it is told solution X dimerizes in water to the extent of 80%, 2.5 gram of X in 100 gram of water increases the boiling point by 0.3 degrees Celsius, the molar mass of X is. So now X, it dimerizes, means two atoms of X will form X2. Since it dimerizes to the extent of 80%, so it means here the degree of association alpha, which is the degree of association here, association, that will be equal to 0.8, since it since the degree of association is 80%. So therefore here n equal to 2, and as you know that for the association of the solvent, for association, the Van 't Hoff factor I is given as 1 plus alpha into n minus 1. So here it will be 1 plus 0.8 into 2 minus 1. So that is 1 plus 0.8. So that is 1.8. Now, no, sorry. This is wrong. For association, we have um, 1 plus alpha into 1 by n minus 1. So it will be 1 plus 0.8 into half minus 1. So that will be 1 minus half into 0.8. So 1 minus 0.4, that is 0.6. So the Van 't Hoff factor I is 0.6, and the Kb for water, that is 0.52 Kelvin kg per mole. And then is told, now therefore we can say that the the elevation in boiling point delta TB, that is equals to I into Kf into m, where m is the molality of the solution. So therefore here the elevation in boiling point is told 0.3 degree Celsius, and I is 0.6 into Kf, that is 0.52 into m is the molality. So molality means the number of moles of the solute, which is 2.5 by x divided by 100 gram. So here we are assuming that, let's say, x gram per mole is the molar mass of x, suppose. Then the number of moles of x, that will be 2.5 by x, and the divide by mass of solvent in kg, so that will be 100 grams, so it is 0.1 kg. So from here we have to solve and find out x. So that will be, so that is 0.3, that is equal to 0.6 into 25 by x into 0.52. So therefore x will be equal to 25 into 0.52 divided by 0.3 into 0.6. So this will be 3 to the 6. So or we can do 100 into 0.52 divided by 2. So that is 26. So x is equal to 26. So it means option C is the correct answer. The molar mass of x is 26 gram per mole. Then here it is told Henry's law constant for the solubility of N2 gas in water at 298 Kelvin. Hmm. Henry's law constant for the solubility of N2 gas in water. So the KH value, that is given as 1 into 10 power 5, 1 into 10 power 5 atmosphere. The mole fraction of N2, the mole fraction X, means chi of N2, that is 0.8. the number of moles of N2 from air dissolved in 10 moles of water at 298 Kelvin and 5 atmosphere pressure is. So here we know that uh, the pressure the pressure of N2, that is equals to the Henry's constant kh into the chi of N2. Now the so here P of N2 is the partial pressure of N2, that is equal to kh into chi. So now the total pressure that is given as 10 power, so that will be the mole fraction of air is 0.8. So in case of in if the total pressure is 5 atmosphere, then the partial pressure of N2 that will be equal to the mole fraction of N2 times the total pressure. So that will be equal to 0.8 times 5 atmosphere, that is 4 atmosphere. Now therefore, so 4 atmosphere is the partial pressure of N2 into kh, that is 10 power 5 atmosphere into chi of N2. So this will happen at so here we have the mole fraction of N2 that is dissolved in water. So here and here it is not, so here we can call it as chi N2 dash, since why it is not the mole fraction of N2 in water, it is the mole fraction of nitrogen in air, mole fraction of nitrogen in air, and this one is the mole fraction of N2, mole fraction of nitrogen that is dissolved in water. So therefore here chi of N2, the mole fraction of N2, that will be 4 into 10 power minus 5, and that will be equal to the number of moles of N2 divided by the number of moles of N2 plus the number of moles of water. Now here number of moles of N2 from air dissolved in 10 moles of water. So now it is given that the number of moles of water, that is 10. So and the number of moles of N2 that is dissolved in water, that we have to find out. Now therefore number of moles of N2, let's say that is equal to n, suppose. So n by n plus 10, that is equals to chi of N2, that is 4 into 10 power minus 5. So therefore now 4 into 10 power minus 5, it means that is a very small value only. So it means we can, it means that n plus 10 we can take it approximately as 10 only. So it means that n is much less than 10, Means n is approximately 4 into 10 power minus 5 into 10, so that is 4 into 10 power minus 4 approximately. So option A is the correct answer. It means the number of moles of N2 that is dissolved in 10 moles of water at 298 Kelvin is 4 into 10 power minus 4 moles. So option A is the correct answer here. Then it is told choose the correct statement. KH value is same for a gas in any solution, that is not the same. So KH value it is different for different gases and for different solvents also. And higher the KH value, more is the solubility of the gas. No, that is also wrong. Lower is the KH value. If the KH value is lesser, then only it means that more amount of gas will be soluble in the solvent. So it means the solubility of the gas will increase then. And here it is told KH value increases on increasing the temperature of the solution. Yeah. So KH value increases with the increase in temperature of the solution. Mm, so and easily liquefiable gases usually have have lesser KH values. So easily liquefiable gases are more soluble. It means that they should have lesser KH values only. So easily liquefiable gas, it means that its solubility in water is also high. Solubility is high, it means that they have lesser KH values. Since as we know, solubility is inversely proportional to the Henry's constant KH. So it means that option C and D both are correct. Both C and D are correct options. Then here it is told the KH value in kilobar of argon, carbon dioxide, formaldehyde, and methane are respectively these at 298 Kelvin. The increasing order of solubility of the gas in the liquid is. So as we know that the partial pressure of the gas that is equals to kh into the mole fraction of that gas in that solvent. It means how much mole fraction of that gas will be soluble in that solvent. So therefore, it means that if the pressure of the gas is kept same, then it means the partial uh, or the mole fraction of that gas which is soluble in the solvent, that is inversely proportional to the value of KH, Henry's constant. So it means that if the KH value is higher, then the solubility of the gas will be lesser. Solubility will be lesser, since if KH value is higher, it means the mole fraction of that gas will be lesser. It means that lesser amount of gas will be soluble in that solvent. So it means that we have to write the increasing order of solubility. So we should first start with that gas which is having least solubility. So least solubility, it means that it should have the maximum value of KH. Maximum KH value will have least solubility. So here the highest value of KH is 40.3, which is for KH value is 40.3 for 40.3 kilobar for argon. So it means that argon is the least soluble, then um slightly lesser value. So KH, so KH is the, if KH is least, then it has maximum solubility. So KH value is 1.83 into 10 power minus 5 kilobar for formaldehyde. Formaldehyde, it means for the third one. So for the third one, the solubility will be the highest. So the third one should be at the last. Then the KH value is 1.67 for the carbon dioxide, which is CO for the second one. So it means the second one will have slightly lesser solubility, or slightly higher solubility than the first one, which is argon. So 1, 2, then 4. Fourth one is slightly lesser than that of CO2. So it has slightly lesser value of KH than that of CO2, but higher than that of formaldehyde. So its solubility will be also higher than that of CO2. So 1, 2, 4, 3. So option A is the correct answer. So hope all of so okay. So then we shall go to the next question. So here it has been told that the vapor pressure of, so here it has been told that the vapor pressure of pure liquids A and B are 450 and 700 millimeter of mercury at 350 Kelvin respectively. So it means that here P naught A, that is given as 450 millimeter of Hg, and P naught B, that means 700 millimeter of Hg. So it is the vapor pressure for the pure solvents. Now, if the total vapor pressure of the mixture is 600 millimeter of Hg, then the composition of the mixture of the solution is. So here, let's say that chi A is the mole fraction of A and chi B is the mole fraction of the component B, mole fraction of the liquid B in the mixture. So now therefore the sum of the mole fractions of A and B, that should be equal to 1 also. And so the total pressure, so therefore we can say that the mole fraction of B, I can say it is 1 minus the mole fraction of A. So the total pressure of the mixture, that is equals to P naught A, P naught A into mole fraction of A plus P naught B into mole fraction of B. So therefore the total pressure of the mixture is 600 millimeter of Hg, and P naught A, that is 450 into chi A plus P naught B, that is 700 into 1 minus chi of A. So we have to find chi A, so that is, this one will be, so chi A into 450 by 600 plus 1 minus, sorry, 1 minus chi A into 700 by 600, that is equal to 1. So 0, 0 will cancel, 15, 3s are 45, 15, 4s are 60, 0, 0 cancel, so 7 by 6. So this will be 3 chi A by 4 plus 7 by 6 minus 7 by 6 chi A, that is equal to 1. Therefore, we can say 7 by 6 minus 1, that is equals to 7 by 6 minus 3 by 4 into chi of A. So this will be 1 by 6. 1 by 6, that is equals to, the LCM is 12. 6 2 are 12, 2 7 are 14, minus 4 3 are 12, 3 is 9 into chi A. So therefore, chi A, that will be equal to 1 by 6 into 12 by this 5. So 6 to the 12, so 2 by 5, that is 0.4. So therefore, chi B, that is 0.6. So it means the mole fraction of A is 0.4 and mole fraction of B is 0.6. So it means that option A is the correct answer. Then it is told that the aqueous solution of alcohol contains 18 gram of water and 414 gram of ethyl alcohol. So there is an aqueous solution. There is an aqueous solution of alcohol which contains 18 gram of water and 414 gram of ethyl alcohol or ethanol, C2H5OH. The mole fraction of water is now the mole fraction of water is okay. So therefore the mole fraction of water, that will be equal to the number of moles of water divided by the number of moles of water plus number of moles of ethyl alcohol. So now the um, molar mass of the ethyl alcohol, that will be equal to 12 to the 24 plus 6 plus 16. So that is 30, so 46. 46 gram per mole. And the molar mass of water, that is obviously 18 gram per mole. So now therefore 18 gram of water, it means that 1 mole of water is there. So therefore the number of moles of water is 18 by 18, that is equal to 1. And the number of moles of the ethyl alcohol, that will be equal to 414 gram divided by 46. That will be equal to so 2 to the 4 to 3 are 6, 2 to the 4, so the 14. So 23 into 9, 3 9s are 27, 2 9s are 18, so 207. So 23 9s are 207. So the number of moles of alcohol, of the ethyl alcohol, is 9. Therefore, the mole fraction of water, that will be equal to 1 by 1 plus 9. So that is 1 by 10. So that is 0.1. So option C is the correct answer. Then here it is told that which of the following colligative properties can provide molar mass of proteins, polymers, and colloids with greater precision. So the measurement of the osmotic pressure is preferred for the de determination of the molar masses of large molecules. So the measurement of osmotic pressure is pro- provides measurement provides the greater precision provides greater precision for the measurement of uh, the molar masses of molar masses of macro molecules, or we can say large molecules, like like proteins, polymers, and colloids. Since we know that osmotic pressure, it depends on the molarity, i- which is equal to ICRT. So here C is the molarity of the solution. So molarity is a so molarity gives a better precision for the measurement of molar mass. And in the case of the other colligative uh, properties, like the elevation in boiling point and depression in freezing point, and the relative lowering of vapor pressure, all these will these d- depend on these depend on m- molality of the solution. So molarity gives a better precision than molality in the determination of the molar mass. So the rule is that molarity gives better precision gives better precision in the measurement of molar mass in the measurement of molar mass than that of molality. So hence the osmotic pressure will pro- provide the molar masses of these m- m- molecules with greater precision. So it means option B is the correct answer. Then here it is told solubility of a gas in a liquid increases with solubility of a gas in a liquid increases with. So according to Henry's law, as we know, according to the Henry's law, the solubility of a gas, the solubility of the gas in a liquid, that is proportional to the partial pressure of that gas, to the partial pressure of the gas in the liquid. So now it means that on increasing the temperature, on increasing, so we can also say that according to Henry's law, we know that the partial pressure of the gas in a liquid, that is equal to kh into x, or I can say kh into the mole fraction of that gas in the liquid. So here, so on increasing the temperature, the value of kh will increase. It means um, the Henry's constant increases, and so the solubility of the gas or the mole fraction of that gas in the solvent, that solubility of that gas, that will decrease. So it means that on increasing the temperature, the solubility decreases. So we should decrease the temperature. So decrease, when there is a decrease of temperature, then only the solubility of the gas will increase in that liquid. And also, and also when the and also if the partial pressure of that gas is increased, then also the solubility of the gas will increase. Since why from here we can also see that the partial pressure of that gas is proportional to the mole fraction of that gas in the liquid. So it means that if the partial pressure of the gas is increased, it means the mole fraction of that gas in the liquid will also increase. It means the solubility of that gas will also increase. It means we should increase the pressure, we should increase the pressure and decrease the temperature, then only the solubility of the gas in the liquid will increase. So option A is the correct answer. Then it is told the rise in boiling point. The rise in boiling point of a solution containing 1.8 gram of glucose in 100 gram of solvent is 0.1 degrees Celsius. The molar elevation constant of the liquid is. So it means that we have to find out the value of Kb. Kb we have to find, where we know that the elevation in boiling point delta Tb, that is equal to I into m into Kb. So therefore the elevation in boiling point, that is 0.1 degree Celsius, and I is the Van't Hoff factor. And here it is told that glucose is the solute which is used, and since it can't form any ions, so I will be equal to 1, since no ions are formed in glucose. So 0.1 will be equal to I 1 into m. M, that is the molality of the solution, means the number of moles of glucose. Now the molar mass of glucose, that is equal to, so we know that it is C6H12O6. So C6 means 12 6 is 72 plus 12 plus 16 6 is 96. So 96 plus 400, so it is 180 gram per mole. It is the molar mass of glucose. So molality of the glucose solution, that will be equal to the number of moles of glucose divided by the mass of the solvent in kg. So it is 0.1 kg. So the number of moles of glucose will be 1.8 gram divided by 180 divided by 0.1. So it is 18 by 180. So that is 1 by 10. So 0.1. So this is equal to 0.1 into kb. So it means that kb is equal to 1. So it is 1 Kelvin kg per mole. So it means the molar elevation constant of the liquid is 1 uh, Kelvin kg per mole. So option D is the correct answer. Then here it is told the if 3 gram of glucose, if 3 gram of glucose uh, molar mass 180 gram is dissolved in 60 gram of water at 150 degrees Celsius, the osmotic pressure of the solution will be. Now the osmotic pressure pi equals to ICRT, where I is the Van 't Hoff factor, C is the molarity or the molar concentration of the solution, and R is the ideal gas constant, and T is the T is the absolute temperature of the solution. So here, the Van 't Hoff factor I will be equal to 1, since glucose will form no ions in the solution. Since glucose forms no ions in the solution. And then C is the molarity, of the solution. So that will be equal to the number of moles of glucose divided by the volume of the solution in liters. So the number of moles of glucose will be 3 gram divided by 180 gram. So the number of moles, and 60 gram of water is used. So we can say that is 6, and we know that the density of water is 1 gram per centimeter, 1 gram per uh, centimeter cube, 1 gram per centimeter cube, or 1 gram per ml, I can tell. So therefore 60 gram means 60 ml. So in liter I should take, so it will be 60 by 1000 liters. So this will be mole per liter. So it is 3 6 18. It is 1 by 60 into 1000 by 60. 0 0 cancel out. So 2 3 are 6, 2 5 are 10. So 5 by 18. So this will be 5 by 18 gram mole per liter or molar, we can tell. So 5 by 18 molar is the concentration of the solution, and R value we can tell that is 0.0821 liter atmosphere per mole per Kelvin. And since we want the osmotic pressure in atmosphere, and T is the temperature of this solution in Kelvin. So that is 15 degrees Celsius. So 273 plus 15. So that is 288 Kelvin. So therefore, the osmotic pressure of the solution, the solution, that will be equal to pi, that is I, that is 1, C is 5 by 18 into R is 0.0821 into T, that is 288. So this much atmosphere it will come. If we solve it, then we will get so 5 by 18. So this will be 5. So we can 5 by 9, 2 9 is 18 and 144. So this will be 5 into 144 into 0.0821 divided by 9, which is 6.57 atmosphere approx. 6.57 atmosphere. So option A is the correct answer. Then here it is told a sample of water is found to contain 5.85% weight by weight of AB and 9.5% weight by weight of XY2, whose molar mass is 95. Assuming 80% ionization of AB and 60% ionization of XY2, the freezing point of the water sample is. So kf value for water, that is 1.86 Kelvin kg per mole, and the freezing point of pure water, it means TF naught. Freezing point of pure water is 273 Kelvin, and A, B, and Y are monovalent ions. So therefore, we know that the depression in the freezing point, that is equals to uh, the TF naught minus TF. It means the freezing point of the pure solvent minus the freezing point of the solution. So here we have to find the TF, means the freezing point of the water sample. So now, since it is a mixture of two compounds, since two compounds are mixed in the solution, so therefore the depression in the freezing point, that will be equal to I1 M1 plus I2 M2 into Kf, where M1 is the molarity of the first compound, and M2 is the molarity of the second compound, and I1 is the Van 't Hoff factor of the first compound, and I2 is the Van 't Hoff factor of the second compound. So now here there is ionization. So for ionization, or we can say for dissociation, for dissociation we have I value that will be equal to 1 plus alpha into n minus 1, where n is the number of ions which are formed, and alpha is the degree of ionization, or the degree of dissociation. Degree of dissociation is alpha here. So now, therefore, here two compounds are used. One is AB and one is XY2. XY2. So they are monovalent uh, ions only, A, B, X, and Y. So therefore, for AB, the degree of dissociation alpha 1, that is given as 80% ionization, so it will be 0.8. And for XY2, the degree of dissociation, that is 60%, so it is 0.6. So now therefore I1, that is the Van 't Hoff factor for AB, that is 1 plus alpha 1, 0.8 into n. Now here for here n1 is obviously 2, since it can give two ions it can give. And here xy2, obviously it can give 3 ions, one x plus and 2y minus ions. So here n2, that will be equal to 3. So I1, that is 1 plus alpha into n minus 1, so that is 1.8. And similarly I2 will be the Van 't Hoff factor for xy2, so that will be 1 plus alpha 2, that is 0.6 into 3 minus 1, so 2 6 are 12, so 2.2. So now M1 is the molality of the first solution. So here it is told it contains 5.85% weight by weight. So 5.85% weight by weight, it means that it contains 5.85 gram. So it means that 5.85 gram of AB is present in 100 gram of the solution. 100 gram of the solution. So therefore, molarity of AB solution, that will be equal to the number of moles of AB, that is here 5.85 divided by 5, 58.5. Since here the molecular mass told is 58.5, that divide by 100 gram of of the solution is used. It means that 100 by 1000 kg. So this will be 0.1 divided by 0.1. So that is 1 molal. 1 molal solution is used for AB. Similarly, M2 will be equal to the number of moles of XY2, that is 9.5 gram is taken in 100. So here also 9.5 gram of XY2 is in 100 gram of the solution. So 9.5 gram by 95 is the molar mass that has been told for XY2. So 9.5 by 95 divided by 100 by 1000. So this one is also 0.1 by 0.1. So that is also 1 molar. Now therefore, um, delta TF, it means TF naught, that is 273 minus TF, that is equals to I1 M1 I1 M1, that is okay. 1.8 into 1 plus 2.2 into 1 into KF, it is 1.86. So that will be equal to 1.8 plus 2.2, that is equals to 4 into 1.86. So therefore TF will be equal to 273 minus 4 into 1.66. So 4 8 the 4 into 1.86. So that is 7.44. So that will be approximately, so 273 minus 7.44. So that is 265.56. So this will be 265.56 Kelvin. So the freezing point of the water sample is 265.56 Kelvin. So option D is the correct answer. Then here it is told that the mass of glucose that should be dissolved in 50 gram of water in order to produce the same lowering of vapor pressure as is produced by dissolving 1 gram of urea in the same quantity of water is. So the lowering of vapor pressure, that is P naught minus PS by P naught, but, where P naught is uh, the vapor pressure of the pure solvent and PS is the vapor pressure of the solution. So P naught by PS by P naught, it is equal to the number of moles of solute by number of moles of the solvent. So here solvent water is used. So therefore we have to do number of moles of glucose divided by the number of moles of water. And that should be also, it is told that should be also same as the number of moles of urea divided by the number of moles of water. Here it is told the same amount of water has been used. So it means the number of moles of glucose should be same as the number of moles of urea. It means number of moles of glucose, uh, let's say the mass of glucose that should be used is x gram, and we know that the m- molar mass of glucose is 180 gram. So x by 180, that is equal to the number of moles of. So why it is 186 is C6H12O6 is the m- molecular formula for glucose. So we have 12 6 are 72 plus 12 plus 16 6 are 96. So if we add them, then we'll get 180 gram. So x by 180 is the number of moles of glucose. That should be same as the number of moles of urea. Now urea is CONH2 whole 2, CONH2 whole 2. So therefore the molar mass of urea, that will be equal to 12 plus 16 plus 14 plus 2, 16 into 2. So 16 3 is 48, 48 plus 12, that is 60 gram. So 1 gram of urea has been used. So 1 gram by 60, that will give you the number of moles of urea. So therefore x will be equal to 180 by 60. So that is 3 gram. So 3 gram of glucose should be dissolved. So option 2 is the correct answer. Then it is told osmotic pressure observed when benzoic acid is dissolved in benzene. So benzoic acid means it is COH, it is called benzoic acid. So that is dissolved in benzene. Benzene means this is less than the expected, is less than that expected from theoretical considerations. This is because benzoic acid gets associated in in benzene. The reason is that the benzoic acid gets associated in benzene, so the osmotic pr- pressure, the theoretical value is CRT, but the actual value is pi equals to ICRT. So here I is the Van't Hoff factor. So the Van't Hoff factor will be equal to 1 plus alpha into 1 by n minus 1 for where alpha is the degree of a- a- association. Alpha is the degree of association. So for association, this value I will be obviously less than 1. So it means the actual value of pi is less than the theoretical value of the osmotic pressure. So the actual value of osmotic pressure should will be less than that of the theoretical value, since the benzoic acid gets associated in benzene. It gets associated. So option 3 is the correct answer. Then it is told which of the following solutions will exhibit highest boiling point. So we know that the elevation in boiling point delta TB, that is equals to I into m into TB, where I is Van't Hoff factor, m is the molality of the solution, and TB is the m- molar elevation constant. So now we we know that the elevation in boiling point delta TB, that will be equal to TB minus TB naught, where TB is the boiling point of the solution and TB naught is the boiling point of the pure solvent, the boiling point of the pure solvent. So here it means that mm, that if, sorry, this will be KB. This will not be TB, this will be KB, which is the molar elevation constant. So now if that I, now KB will be the same for all the four solutions since the solvent is the same. Now if I into M is higher, the value of this I into M is higher, then only the elevation in the boiling point will be higher, and it also means that the boiling point will be higher. So now for the option 1, the value of I into M, that will be equal to 3 into 0.01. So the I value will be 3 since why sodium sulfate that will give 3 ions in the solution, 2 Na plus ions and 1 sulfate ion. So it will be 0.03. And for the second option, it is the I into M value, that will be I will be 2, since why KNO3 will give 2 ions, 1 K plus and 1 NO3 minus ion. So 2 into M, that is 0.01. So that will be also 0.02. And third option is 0.15 molar urea. So 1 in I into M, that will be equal to I is 1 only, since urea will give no ions. It gives no ions. So the Van 't Hoff factor I will be equal to 1 only. So 1 into m- m- the molality, that is 0.015. So that is also 0.015. And the fourth one, for the fourth one, it is for the fourth one, I into M value, that is 0.015 molar glucose. So for glucose also it will give no ions, So here also I value is 1 and molarity is 0.015. So here also 0.015. So the maximum value of I into M is for the first option. So for the sodium sulfate solution only, the elevation in boiling point will be highest. So the boiling point TB will be also highest. It's also highest for the sodium sulfate solution. So the option 1 is the correct answer. And then here it is told the swelling in feet and ankles of an aged person due to sitting continuously for long hours during travel is reduced by soaking the feet in warm salt water. This is because of this is because of osmosis. Since why the when he will keep his feet in warm salt water, then the solvent will move from lower concentration region to the higher concentration re- region, and the swelling in his feet will be reduced. So it happens due to the process of osmosis. So option D is the correct answer. So hope all of you understood the solutions of all these questions based on the previous year KCET exam on the chapter solutions and colligative properties. So still any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. And please install our Sapience education application also, where we shall upload some more uh, im important questions on every chapter on chemistry based on the previous year KCET exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.